Well, Jennifer, I think, is one of the most intelligent people that I've ever met.
Jennifer comes across as a deep scholar, somebody who has spent her entire professional life thinking deeply and continuously about a particular set of biological problems.
She has sort of a glow about her that when she walks into the room, people just know that Jennifer's there.
And that wisdom and depth comes across in pretty much everything she does.
I love the process of figuring things out. It's like Richard Feynman once said, it's the process that's so wonderful. I feel just incredibly grateful that I figured out a career for myself that allows me to do that, ask questions about nature and figure things out that, every now and then something nobody's ever realized before comes to light. And that's awesome. I love that about the process of doing science. And frankly, doing it with a team of great people, collaborators, students, et cetera, is just, the best.
Most people think with someone who's as famous as she is, they would sort of put a barrier between you and her. But in fact, when anybody's talking to her, even a student is talking to her, or a high school student's talking to her, she gives them all the attention.
And speaks with seasoned, distinguished peers with the same kind of attentive, sincere warmth.
I'm always looking for, first and foremost, people that are excited about their work, that are fun to work with, who enjoy the process of discovery as I do, who are really in it for those reasons. They want to understand the truth. They want to go after a question and really track it down to its core and figure out the answer using experiments and data that will hopefully direct us to the truth about nature. Either it's a nugget or sometimes it's a bigger piece of understanding that we come to. And I like to find people that share that passion.
What sets Jennifer apart is that whatever she does, she stays true to her science and is remarkably humble, despite the fact that her discovery has and will change the planet.
I like to face challenges head on. I don't like to run away from them. I like to just grapple with them, struggle with them. Often the process, the struggle is really what leads to real insight in my experience. It's a process of struggling. And I often tell my students that when things are hard, that means you're going after an important problem. If it was easy, somebody probably would have done it already.
Jennifer has, for lack of a better term, nerves of steel. She has an amazing ability to stay calm in front of any storm. Jennifer's discovery has given all of us a supersonic jet to go from where we are now to where we'd like to be.
Well, Jennifer, as the inventor, has become essentially the face of this amazing technology, and she's thought about what does it mean not only for industry and for biotechnology as a therapy, but also thinking about it as all sorts of tools for diagnostics.
And so what do we do with that extraordinary opportunity? And I think that for me, as somebody who's been sort of thrust into this at some level, and I'm sort of in the center of it in some ways, I really want to see the Bay Area, and especially with our entrepreneurial climate here, really take the lead in applying genome editing to solve real problems. And I think that both in biomedicine and agriculture, there are just extraordinary opportunities.
She's also thinking about the ethical and the societal effects of this.
Jennifer is also one of the most determined people I have ever met. When she sets sights on a goal, rest assured she'll get there.
In the biomedical areas, to have the opportunity to cure genetic disease for the first time and do that with a level of accuracy and safety that is really unprecedented. I mean, that's just extraordinary. I don't want to do that and bring that about in a way that costs $1 million for a patient. That's just not going to be viable, and it's not exciting to work on something like that.
In thinking about how history will judge the present moment and the role of Jennifer's discovery, I go back to the end of the 19th century, when we had classical physics. And then we discovered the structure of the atom, and quantum mechanics came along, and humanity entered the modern age. I think Jennifer's discovery represents that caliber of an inflection point.
right now, we're living through this incredible moment in the biological sciences, and I don't say that lightly. It's an absolutely transformative time where the tools and technologies for manipulating biological systems and investigating biological problems and questions has never been this robust and advanced. And the pace at which technology and science in general is moving ahead is just breathtaking. In genome editing, we're literally probably a few short years away from being able to make any change to any genome in any organism with absolute precision. And I don't say that lightly. That's not hyperbole. That's absolutely going to be true.
A door into a world where we understand life in an unprecedented depth, where we are able to treat and prevent disease in a way we've never been able, and where we've created a new kind of agriculture to feed a growing and warming planet.